file. We can plug it into this computer. We can boot it into Linux. We can boot it back into Windows. Depending on which operating system you need to run your presentation. On the other hand, if your presentation is about the projector, then you have to bring your projector. Now, why do I say that? Why do you guys say?
You don't want us to go to the school's projector.
No, it's because projectors are now getting smaller and they're getting more cost effective. They have personal projectors that can run on batteries, so they're rechargeable. They're rechargeable projectors. I think they cost somewhere between $200 to $300.
They actually have them. They sell them at CVS now for like $80.
Yeah. But they're not really good, they're not really bright, so they're only good enough to project maybe this much distance and get a screen size about yay big. Anything beyond that will require a completely dark room. So they're not really practical beyond, it is a cool toy, but projectors have come down in prices. For $400 or $500, you can get a fairly functional projector already for a smaller room. Yep.
I think they were saying that had a projector for a phone or
yes.
Images up.
Yep. Yep. And I think they were proposing to make it wireless too. So your phone can send video content to the projector wirelessly. It's probably Bluetooth, but they have to work out something that has a high enough bandwidth to show video content. So that stuff is coming, and that's why I kind of mentioned, if your point is to present the projector itself, then obviously you have to bring the projector. It'd be kind of funny to have, to have a projector in your pocket and you accidentally turned it on. That would be kind of funny because you'll be walking around at night with light, coming out of your pocket. Perfect Halloween, trick, I guess. You can project a ghost, somewhere and really, that would be a pretty interesting thing to do. Smoke and mirror. Okay, so we are still shopping for a computer. We are shopping for a desktop, I think.
Yes.
Okay, so where are the desktops? Now, one thing I do want to talk about today is not just the desktop computers versus the laptop computers. Desktops, there we go. Popular deals. The Dell website, just like any other website, have daily deals, because they want people to go back and check on their prices, every single day. And it doesn't matter which one we were talking about. I think we picked the medium line one. Let's go back and pick it. We picked the high one? Highest? Okay. Well, let's go pick this one, and we'll go ahead and customize. So my question that I really want to answer is it worth the money to upgrade the processor, say from a 650 to a 760? Is there a way to technically calculate, is it worth the extra money so the computer that I buy today is faster so it does not get obsoleted as quickly? That's usually the argument, right? I mean, if you ask someone, do you want to buy a computer that's more expensive because it is faster now and it does not get obsoleted as quickly? The question is, how much time are you buying for how much money? That's the question. So what do you think will determine that factor? Yep.
The speed of the processor and what you're doing with it. What programs are going to be using it.
That's true. That is true. But a particular law is going to dictate how much money or how much time you're buying with your money. Go ahead.
Like every 2 years,
Yep. You're talking about Moore's law. It is every 18 months you get twice the processing speed. Okay? So that's Moore's law. So what I want to do is to show you, in a spreadsheet's point of view, what we are talking about here. So if you're just talking about, technically speaking, if I buy a more expensive computer today, to try to save myself the trouble of having to upgrade again, how much time am I buying by buying something that is more expensive? So the question is, okay, let's say we have months here. Okay, so we have month 0, month 1, 2, 3, and so on. And then we have the processing speed. So in month 1, it is 1. In the subsequent months, it will be let's see, it'll be 1 times, let's see, how should I do this calculation? No, because it doubles every 18 months, so I have to find the exponent coefficient to make it happen. I have to use the caret symbol to use the exponent, but I have to find out what is the monthly increase of speed first. So that would be the log of, it'll be the log of 2 divided by 16. That would be the exponent that I'm talking about. Yeah, so that would be 2. Okay, there we go.
You did it by 18, not 16. Yeah.
Hmm?
You did it by 18, not 16.
18 was the right.
Yeah, 18 is the right. 18 is right.
Oh, you
Yeah.
said 16.
Oh, I'm a natural liar. What can I say? I should get into politics or spy or something like that. Spy is good. And I will be saying this. But then I can also make it easier because I can say this times that. So that way I can just extend this. Uh-oh. Oh, I see why. Because it is B. I forgot about the absolute. Okay, there we go. Okay, so that's working. We'll extend it out to 18 months. And this one is wrong. So, oh, okay. Okay, this is projecting up to 2 years. That is not right. Because in 18 months it should have doubled already, so my equation is wrong. This number is incorrect. Log 2 divided by 18. So this is 2 to the power of that times C1. That's times C2. Huh?
Sorry, it's the opposite version, so it's not miscounted.
Well, this should be compounding already because of that. Ah, no. Okay, let me think about this. This is log of 2. Unless this is not natural log, this could be a log of... There we go. Okay, I was using the wrong log base. In most calculators, when they say log, it refers to the natural log. When they use log 10, it is using base 10 as a log. I think this one, it's still wrong. Okay, this is the natural log of 2. And this would be, oh, I see. This would be the exponent itself to the power of that. So that would be...
When you just raised 1, that exponent.
It should not be a 1, that's the thing. I mean, it should not be 2.
Right.
Oh. Log of 2. Because it's the natural log, so the base has to be the natural log number, e basically. So how do you get exp1? I should do it. Yep, that works. And it should be exactly 4 in 36 months, so this is working just fine. Okay, so now we can format, so we can make everything a little bit easier to see. So we go to numbers, we reformat everything to have only 2 digits, and then we use the optimal width. So this way we can basically just look at more columns at the same time. And you can see at 18 months we're doubling the speed of the computer already. So now the question is, how much do you think the system is faster when you pay more money into it? Okay, that's the question. And of course, how much faster you can experience is based on what you're doing. When you compare these processors, okay, let's say you're comparing the i5-650, which is a dual-core processor, to an i7, 870, which is probably a quad-core processor. You can argue that the quad-core processor is twice as fast, but it's not always the case because it depends on what you're doing. If you're doing video encoding or transcoding all the time, yes, definitely go for the 870 because it will make your life a whole lot easier. On the other hand, if all that you're doing is Excel spreadsheets, word processing for your English papers, and so on and so forth, getting the i7 870 is going to be faster, but it is not going to be noticeable. Okay, because what it is doing is when you type something, from the time you press the key and the time that your text document is properly updated, that time will shrink from, say, 2 milliseconds down to 1 millisecond. Well, 2 milliseconds is twice of 1 millisecond, but can you differentiate 2 milliseconds from 1 millisecond? Probably not. Okay? So all that speed, gain of speed is not going to be noticeable, and as a result, it's not worth the money. Yep.
Let's say you're using the portable apps too. That would throw the whole equation out of it.
Yep, because portable apps are slow because of the media that you're using. Exactly. So you have to look at all those factors, but even if all the factors are the same, you're doing pure computation, this spreadsheet gives you an idea. If you buy a processor that is, let's say, 20% faster, you're just buying 5 months of time. That's all you're buying. Okay? Does everybody know what I'm talking about? You spend more money to get a faster system. Let's say that the faster system is, on the average for the stuff that you do, 20% faster. What you're doing is you're gaining 5 months of time. That's all you're buying. It's 5 months. Okay? So the next question is, how often do you upgrade your computer? How often do you buy a new computer to replace your current computer? It depends on many factors, but most people don't really replace a computer every 18 months. Okay, most people will hang on to a computer for at least 3 to 5 years. Okay, so 5 months within 5 years is nothing. It is insignificant. So from that perspective, it really shows you, if you're getting 20% more performance, you're basically buying 5 months of time. Is it worth the money? Is it worth $300? Is it worth $400? Is it worth $500? I don't know. It depends on you. Okay? But this is one way of looking at it using Moore's law. Okay? Moore's law is what I have used here. Yeah.
So basically, for me in particular, I run the portable app since I started using that, and I'm using it on 5 different systems.
Mm-hmm.
Basically, it would not benefit me at all to upgrade.
Now, are you using a memory stick right now? What you can do is instead of investing in a faster computer, because you're not even using the same computer all the time,
Right.
because when portable apps is useful, it means that you're using those portable apps on different computers. So in your case, it makes more sense to go for a faster way to talk to the external media. So one thing you can do is to get an external hard drive, because external hard drives are faster than flash-based memory. Or if you like solid-state stuff, you can go buy the 400X compact flash cards and get a flash card reader to read it. Okay. Let me just show you what I mean by that. And we can go to, say, Amazon.com. It's just easy to search for products at Amazon.com.
Shouldn't computers these days have a built-in card reader?
Yes, they do. But not all computers. If he's after portability, then you cannot make the assumption that you have a card reader.